Hello class, welcome to Pre-Algebra Lesson 4.4, which is all about solving percent of change and percent of error problems. By the end of this lesson, you should be able to solve problems involving the percent of change and the percent of error. So the first example we are going to look at involves an increase, and we want to figure out what percent is something increasing by. Okay, and that increase, or in a future example, decrease, we call that a percent change. Okay, so how much something has changed in relation to its original amount. Okay, so what is the percent change of the alligator's length? And if we look at this image, we have the very top one is 32 inches last year, is how long it was originally, and then this year its new length is 38 inches. So what we do is we can still use that percent equation that we practiced yesterday, where we do part equals percent times whole. Okay, and the part for these problems is the percent change, or I guess the not percent change, it's just the change, my bad. So part equals the number of change. So in this case, originally the alligator's length was 32 inches, but this year it is 38 inches. That means that it grew 6 inches. So in this case, our part is going to be 6 equals, and then we don't know what our percent is, so I'm just going to use a variable. And then our whole, what was the original? It was 32. And then just like yesterday, in order to get that 32 over to the other side, you would divide. So 6 divided by 32 equals our percent, and 6 divided by 32 is 0.1875. And if I were to convert that to an actual percent from that decimal, I would get an answer of the percent change was 18.75%, and then I would describe it as an increase. Okay, so sometimes a problem will ask you to list not just the percent, but also say, was it an increase or decrease? Okay, so with that in mind, what will be the length of the alligator next year if it changes by the same percent as it changed last year? So the percent it changed by last year, what we just solved for, that was 18.75%. And then basically what you're doing is you're taking that 38-inch alligator as your new original. Okay, so in this problem, you're not actually finding like the percent change. Now you're practicing what we did yesterday in lesson 4.3. Okay, so you have a percent, you have our whole, we need to solve for the part. Okay, and once you have that part, you need to think, is that your final answer if you're looking for the length of the alligator? Good luck. All right, hopefully your final answer was 45.125 inches, or maybe you rounded and just said about 45 inches. I'm okay with that. The way that I got this was I took that 18.75%, converted it to the decimal 0.1875, and multiplied that by the whole, which was 38. When I did that, I found that the parts, or the number of inches it changed by, was 7.125. And I took that part and I added it back to the original in order to figure out what is the new length of the alligator. If you have questions about that, please ask for some help. I am happy to help you. Let's look at example 2. Now we're going to practice finding a percent decrease. Okay, so last year a website had 40,000 visitors, and this year it has had 37,000 visitors. What is the percent change in the number of visitors to the website from last year to this year? Okay, so we have, remember, part equals the percent times the whole. And on example 1, we talked about how the part is how much it changes by, right? So in this case, those two numbers are 3,000 apart. And specifically, this one went down 3,000, right? From last year to this year. So I could represent it with a negative 3,000. And then I don't know what the percent is, but the original was 40,000. So now what I would do is I would divide both sides by 40,000. So I'm going to say negative 3,000 divided by 40,000 equals my percent. And if I were to do that, I would get a negative 0.075. And if I convert that to a percent, it would be a negative 7.5%. And since I used a negative, that represents my word decrease. Or something else you could do is if you had said that it just changed by 3,000, you would still do that same process. It's just you would get P equals a positive 0.075. So for your final answer, you would have to include the word decrease. Okay, so you can represent the decrease with either a negative sign or writing the word decrease. I would personally accept either. Okay, but pay attention to what your online book is asking you to do as you complete your assignments. All right, let's look at example 3, which is finding the percent error. So Sean estimated that the attendance at a college lacrosse game was 3,000. The actual attendance was 3,296. What is the percent error of Sean's estimate? Round to the nearest whole percent. Okay, so for this one, we are going to be comparing these two numbers, right? What Sean thought it was, this was his guess, and then this was the actual. So the first thing I'm going to do is I'm going to figure out how far apart are those two numbers. So 3,296 minus 3,000, that's going to be 296. So he was off by 296 people. Then that's going to represent your part, just like when we did our percent of change. And you're going to do the part equals the percent times the whole. And for this problem, the whole is going to be represented by the actual, right? Because we are comparing Sean's estimate to the actual. So in this case, we're going to multiply by the 3,296. And if I were to do that, then that means I would divide by 3,296 in order to get my percent, and that's 0.0898, and then it continues on, but I'm going to just say 0.0898 is approximately equal to P. So that little squiggly equal sign just means that I'm rounding, okay? And if I were to round to the nearest whole percent, I would have, let's see, 8.98%. The nearest whole percent would mean I have to get rid of the decimal, so that 9 would bump this 9 would bump this whole number 8 up to a 9 as our answer. So I would say it was a 9% of error. And I would say that it's about 9% error. So you don't actually have to include the word the. You can just say about 9% error. Okay? So hopefully that doesn't seem too bad. And the last question for you to do is to find the percent of error for this problem. We have the specification for the length of a bolt is 4.75 inches. A machinist makes a bolt that is 4.769 inches long. What is the percent error of the bolt's length? So when you're looking at these two problems, you're going to do the same thing that we did on the last one in order to find the part. But then if you're wondering which one do you use for the whole, you want to, in this problem, use the number that it's supposed to be. So in this case, the goal, the ideal length of this bolt is 4.75. That means that's what you're going to use as your hole because that's what it's supposed to be. Okay, good luck. All right, for this problem, hopefully you determined that it was about a 0.4% error, and you found that by doing 4.769 minus 4.75 to find the change was 0.019. And you said 0.019 equals the percent times what the length of the bolt was supposed to be, 4.75. You divided by 4.75 to get 0.004, and since we moved the decimal 2 places to the right to go from a decimal to a percent, that leaves me with 0.4% error. Okay, so if you have any questions about that one, or anything from this lesson, please be sure to reach out for some help. I'm happy to help you. Here's a little summary of what we talked about today. I hope you guys have a great day.